So, we are doing the unit circle today, and it comes from the combination of special right triangles and a unit circle. And so I passed out a pen because I want you to use two colors so we can kind of keep things a little bit straight as we're going through. So I'm going to use two colors today too. So she should have like a pencil and something else. So it comes from a combination of special right triangle relationships, and what was here before, they just present it to you. Like, here's this thing that you need to memorize. And once again, I hate memorizing things. It is really easy to build it. And so that's what we're going to do. So you should have your little jam jar lid and a protractor, straight edge. And so to get started, we want to talk about special right triangles. And there are two special right triangles. The 45, 90 degree special right triangle. And then there's also the 30, 60, 90 special right triangle. So you can see that we're going to use two different colors here. Now, before we even go to the special right triangles, we want to talk about how this relates to creating our circle. Well, these are our friendly angle measures, okay? They are special right triangles, so these values happen to be incredibly friendly. And so what we're going to do to get started is you want to give yourself plenty of room, but I have sort of towards the bottom of the page maybe. Go ahead and trace carefully your little jam jar. Give yourself a nice circle. I wish it were slightly bigger for this particular task, but it'll do it. And then I also go ahead and take your protractor and as close to through the center as you can of your circle, draw horizontal, just so we have like a, well, really, I guess we could do our horizontal and vertical axis. So what I'm drawing here, as close as I can, this is going to be the start of our unit circle. And what we want to understand about the unit circle is that it's a circle, and it's centered on my XY axis. But not only that, it is one unit. It has a radius of 1 unit. So if the origin is right here at 0, 0, and my radius is 1 unit, what's this ordered pair right here? 1, 0, right? Okay. So that is our first point. And what I want to do is we can go around the circle. Then if I know that my radius is 1, well, what's this point right here? 0. It's the ordered pair 0, 1. And then right there. So label your other 4 points. Label those other 2 points there.
Bless you. Bless you. Thank you.
Okay. All right. And so over here, this is the ordered pair, what? -1, 0. And straight down would be 0, -1. Good. So those are the 4, those are called the quadrantal because they fall on the quadrant side. So they're called quadrantal angles. But now, let's see. So we want to talk about our angles. So back to the beginning here. we have the 45, 45, 90 triangle. We're going to get to that in just a second. But I want to find all those angles here on my unit circle in radians. Okay? So, an angle in standard position starts right here on the positive x-axis. And it opens up and starts opening up around my circle. And to get all the way around my circle, how many radians does it travel? 2 pi, that's right, 2 pi. So it was 2 pi radians all the way around. It started here at 0, it opened up and went all the way around and traveled 2 pi radians. And then, but what if it started here at 0 and it traveled around and it landed right here? How far did it travel? 1 pi, yeah, it's just 1 pi radian. Okay. All right. And so we know then that 2 pi is how many degrees? 360. And 1 pi is how many degrees? 180 degrees. Good. Now, let's say I'm going to start here at 0 for my angle, and maybe, what if I stop right here? What's this angle?
1 pi.
90 degrees, but it's also half of pi, isn't it? Because here is pi, and so to stop here would be half of pi. Yeah, you good with that? So I'm going to call it pi over 2, or 1/2 pi, but you also know it as 90 degrees, so that's fine. Okay, so 0, 1 pi over 2, 2 pi over 2, and what's this one going to be called? 3 pi over 2. And what would this one be called? 4 pi over 2. And 4 pi over 2 reduces to 2 pi again. Hey, okay, so counting is cool. And you said 270 degrees. That's good. All right. So now, I'm trying to get to my 45, 45, 90 here. If I'm at 180 degrees, how do I get 45? What do I have to split it into? 4 equal parts. Yeah, if I take my pi, or 180 degrees, and I split it into 4 equal wedges, let's see, I'm going to put a dot right here, and a dot right here. So now you can see we have 1 wedge, 2 wedge, 3 wedge, 4 wedge. 180 divided by 4 is 45. Okay. Pi divided into 4 equal parts is pi over 4. Yeah. So this is 1 pi over 4. What's this dot? 2 pi over 4. What's this dot? 3 pi over 4. And this would be 4 pi over 4. And the rule was whatever we do to the top, we also do that to the bottom. So I'm going to split up my bottom with a couple more dots here. All right, so I was counting. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. What's this one? 5 pi over 4. 6 pi over 4. What is 6 pi over 4 reduced to? 3 pi over 2. Isn't that kind of nice? Okay, so 6 pi over 4, and then over here would be 7 pi over 4. All right. Fantastic, ladies and gentlemen. You just broke our circle, our unit circle, into a bunch of 45, 45, 90 triangles. And so to connect my vertex to my central angle to go out, what I just created was this angle right here that happens to be pi over 4 or 45 degrees. All right, 180 divided by 4 is 45. Pi divided by 4 is pi over 4, 45. So, what do we do with that? Now, let's take our other color. And I'm going to keep doing some counting and dividing here. So we just found all our 45 triangles, okay? I'm going to also find out my 30, 60, 90. Okay, so that's what I'm looking for. If I have 180 degrees, what do I have to split it up into to get 30? 6. Good. So here I am at 180 degrees. I'm starting here at 0, going to pi, and I want to cut pi into how many wedges? 6. Okay. Because if I take pi and I cut it into 6 even pieces, that would be taking 180 and dividing it by 6, and that's going to give us 30-degree wedges, all right? So I'm going to go here. I can cut it right there. There I got 2 wedges. You have to ignore what's already here, okay? That's why we're using a different color, all right? Now, here's my 2 wedges. I got to split that into thirds. So 1 and then another dot there. And so now here is 1 wedge. And that little pink wedge right there is pi over 6. 1 pi over 6. All right, I'm going to split my dots up. So I got to split each quartile into 3 little slices. So I got to do that all the way around. Okay. So on each of these dots, each of these also pink dots, each of these little wedges is the size of pi over 6. So here's 1 pi over 6. My next pink dot is going to be 2 pi over 6. 2 pi over 6 reduces to pi over 3. Okay. So, but we can also call it 2 pi over 6. Okay. All right. So 1 pi over 6, 2 pi over 6. What's this one? Yeah, 3 pi over 6, which also reduces to 1/2 pi. Okay, isn't that cool how everything just kind of reduces? I think it's really neat. Okay, so 1 pi over 6, 2 pi over 6, 3 pi over 6. What's this one? 4 pi over 6, which reduces to 2 pi over 3. All right, so that was 4 pi over 6. And then here is, let's see, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Yep. And here we would have 6 pi over 6, and then down here, 7 pi over 6, and down here, 8 pi over 6. I'm going to leave it for now. 8 pi over 6. And then here we have 9 pi over 6. What's this one? 10 pi over 6. And last, 11 pi over 6. Now I left these out because they'd reduce. And so we do typically see them in reduced form. This would be 4 pi, okay, gentlemen, over 3. 9 pi over 6 reduces to 3 pi over 2. And 10 pi over 6 reduces to 5 pi over 3. Okay, ladies and gentlemen, you just counted out all your friendly angles. and it's kind of nice to just be able to count them. 1 pi over 6, 2 pi over 6, 3 pi over 6, okay? These are all the friendly angles that make up these little special right triangles. So now that you have all those friendly angles listed, we want to go back to our special right triangles because there's some nice relationships. So the 45, 45, 90. Are you with me thus far?
No. Yeah.
Oh, it's because William isn't there to explain.
William never helps.
I need to write one.
He's too smart to help.
He doesn't even do it.
That's not true.
Okay, that's all I needed.
You good? You got it? Okay. All right. So we're going to start with a 45, 45, 90 triangle. And so here I've drawn my 45, 45, 90 triangle. Which means that one of these angles is 45. The other angle must also be 45. And if the angles are the same, what do we know about the side length? They're also congruent. Yeah, they're the same. Now, so what I'm going to do here is I'm going to start with a side length of 1. So we're going to pretend that the leg here has a length of 1, which means the other one must also have a length of 1. And can I figure out this, the length of, I'm just going to call it R. It is. How did you get that? Oh, you did the Pythagorean theorem. Awesome. So you did 1 squared plus 1 squared equals the R squared there. Okay. So 1 plus 1 equals the radius squared. So that's 2. And then how do you get R by itself? Square root both sides. Okay. All right. So the R is the square root of 2. Okay. So that is equal to the square root of 2. And this is true for any 45, 45, 90 triangle. It all boils down to these really nice ratios. And when you know these really nice ratios, you can ask yourself questions like, hey, what's the sine of 45 degrees? Well, the sine of 45 degrees, so looking from this 45-degree angle would be what over what?
1 over this
1 over square root of 2. Yeah, opposite over hypotenuse, right? Okay, good. Which would rationalize, and if we rationalize it, what do we get? Radical 2 over 2. Good, good, good. I could also do like the cosine of 45 degrees. So looking again from my 45-degree angle, what would the cosine of 45 degrees be? 1 over radical 2 again. And if you rationalize, what do you get? Radical 2 over 2. Okay. And then I can also ask you, hey, what's the tangent of 45 degrees? You get 1 over 1, which is, of course, just 1. Okay. So kind of interesting. We can ask those kinds of trick questions with our little special right triangle relationship there. But what I want to do now is I want to take this special right triangle and I'm going to shrink it down. I'm going to shrink it down so that it fits in my unit circle. But right now, this is my radius. If I were to drag this down here, it'd be a little bit too long because the square root of 2 is a little bigger than 1. It's 1.414. Okay. Now, in order to shrink it down, all I have to do is I have to do something to take this so that it becomes a 1. What can I divide by to turn this thing into a 1? Yeah. So I'm going to divide every single thing by the square root of 2. That way, this triangle shrinks down, and now I can fit it right here where I drew my little line before, and here it is. All right, there that 45, 45, 90 triangle is now. And I can figure out this ordered pair because I actually know the length of this side. Well, it was right here. It was a 1, but I had to shrink it down, so I had to divide by radical 2. But I'd rationalize that, and what do you get when you rationalize it? Radical 2 over 2. So this x length is radical 2 over 2. Now what's the y length? Also radical 2 over 2. So this y length is also radical 2 over 2. And so if I go to the other, here's another 45 right here. And I can drop my altitude. So here's my other 45-degree angle. It's really 135. And the little reference angle is 45. What's the length here? What's the x length here? Negative radical 2 over 2. And what's the y length? Radical 2 over 2. It's exactly the same because it's the same exact size triangle, just in a different quadrant. So what about down here? Here's the other 45, 45, 90. What's the ordered pair for this one at 5 pi over 4? Negative radical 2 over 2. And what's the y length downward? Negative radical 2 over 2. And over here we have 7 pi over 4. That's another 45, 45, 90. What's the x value? Positive radical 2 over 2, then negative radical 2 over 2. So just knowing that first quadrant is super nice. And all we have to do then is just change the signs. All right, we'll talk more about those in a second. All right, let's talk about our 30, 60, 90 now. Now, a 30, 60, 90, we're going to build this thing. Again, I like just knowing where it comes from, I think. This is an equilateral triangle. All 3 sides are the same. And we're going to say that they all started with a side length of 2. If they all started with a side length of 2 and it's equilateral, what are the measures of all these angles?
45 degrees.
60, 60, 60, 60, yeah? 60, 60, 60 adds up to be 180 degrees on a triangle? Okay. So what I'm going to do is I'm going to drop an altitude here from this vertex down to this opposite side. And that's going to be perpendicular. And I created 2 right triangles. Not only that, but it bisected this side. And so now that 2 broke into 2 ones. So now we have a side length of 1 and a side length of 1. And it also split my angle. Started out as 60 degrees. What's this little angle now? 30. And 30. All right? Because we split it up. So what I did was I just created a lovely 30, 60, 90 triangle with a couple of nice side lengths. But once again, I need to figure out this side length, this x length here. So how can I figure out that length of x? Okay, I'm going to do it. X squared plus 1 squared equals 2 squared. So again, leg squared plus leg squared equals hypotenuse squared. So we get x squared plus 1 equals 4. We got to subtract the 1. So x squared equals 3. And I can square root both sides. And what do we get? Square root of 3. So here we have the square root of 3 for this x length. And again, when you have this lovely little 30, 60, 90 triangle, you have side lengths. And now I can ask you all kinds of questions like, hey, what's the sine of 30 degrees? And you can look at those. Here's your 30-degree angle. What's the sine going to be? Opposite over hypotenuse. So that would be 1 over 2. So 1/2. Okay, nice. What is the cosine of 30 degrees? Adjacent over hypotenuse. That's so the adjacent is radical 3 over 2. So radical 3 over 2. And then what is the tangent of 30 degrees? Mm-hmm. 1 over radical 3, which would rationalize to be radical 3 over 3. Good. And so when we have this nice little 30, 60, 90, we can find those sine, cosine, and tangent ratios. But I would sure like to shrink it down and fit into this nice little unit circle. So just like before, right now, this triangle has a hypotenuse of 2. But I need to shrink it down so it only has a hypotenuse of 1. So what do I need to divide by?
2.
Yeah. So I'm going to divide everything by 2. 2 over 2 is 1. So it's going to fit inside my circle now so it has a radius of 1. And now I have this side that's a 1/2. And my x side is a root 3 over 2. So here I can drop my altitude here. So here is my little 30-degree triangle. There's my little 30-degree angle right there. And I want to know what is this x distance and what is this y distance on this triangle. How long is this x distance? It's pretty long. It's right there. Radical 3 divided by 2. Radical 3 over 2. And what about this little short leg right here? It's 1/2. These two numbers, radical 3 over 2 and the 1/2, the 1/2 is the short leg, and the radical 3 over 2 is going to be the long leg, which is really kind of nice. Let's see, over here, I'm going to draw it here to 5 pi over 6. That's 150 degrees. Drop down at altitude. So here is another little 30-degree angle right there. And again, I want to figure out this ordered pair. How long is this length right here?
Radical.
Yeah, negative radical 3 over 2. And then how tall is the shorty? Positive 1/2. Very good. Right here at 7 pi over 6 is that same sort of really little teeny tiny little triangle like that. And so again, to get to this point, I have a long leg and a short leg. So what is this x distance? Negative radical 3 over 2, and then negative a half. And then over here at 11 pi over 6, similar thing here. Again, we have an x distance, the long leg, and then the short leg to get down here to this little ordered pair. Positive radical 3 over 2 and negative a half. Good. Are you good so far? Okay. So it is kind of a lot together. What about this dot right here? What's happening here at pi over 3? Well, how big, what degree measure is pi over 3? Think pi is 180. Pi is 180.
60.
Divided by 3 is 60. So this whole angle now is 60 degrees to get there. It's the same triangle, it's just flipped. It's just rotated. So now it's still a 30, 60, 90 triangle, but here we have a short leg and then the long, tall leg. So what's the ordered pair to get here at pi over 3? What's my x distance? 1/2. And how tall is that long leg? Radical 3 over 2. Good. What about at 2 pi over 3? Again, what's my x distance? Negative a half. Little short leg, little short distance, negative 1/2. Positive radical 3 over 2. Good. Same thing down here at 4 pi over 3. 8 pi over 6 is in the way. There you go. Again, to get to 4 pi over 3, I got to go a little short distance and then a long leg. So short leg, long leg. That's going to be negative a half and negative root 3 over 2. And then to get to 5 pi over 3, again, to get there, to travel there, you go short leg and then long leg down. So shorty 1/2 and negative root 3 over 2. Ladies and gentlemen, you just built the unit circle, okay? Most teachers just sit there and say, here it is. You can Google it. It's there. Type in the unit circle. It'll pop up. But I want you to know where it comes from and where all these numbers come from, okay? Really, there's not too many numbers to remember. The ones and zeros are super easy. There's only 3 real numbers we need to know, which is radical 2 over 2. That happens on all the 45s. Oh, yeah. Radical 2 over 2 happens on all the 45s. And then our 1/2 and the radical 3 over 2, our short leg and our longer leg. These are the only real numbers we have to know. And all I think about is short leg or long leg. So if you can remember those things, which one's the shorty and which one's the tall one, then you'll know whether it's 1/2 or radical 3 over 2. Now, what do we do with all of this? When we're asked for the sine, cosine, and tangent of these friendly angles, we can always just draw the little triangle and put our 1, radical 3, 2, and figure out our little ratios like we did. But this is where the unit circle can be helpful. When I look at my unit circle, I can say, hey, what is the sine of 30 degrees? Or rather, sine of 30, let me do sine of pi over 6, okay? The sine of pi over 6, well, here's pi over 6. And it has a triangle associated with it. The sine is, if here's my little 30-degree angle, my little pi over 6 angle, opposite over hypotenuse. What's the length of this opposite side? It's 1/2. Yeah. All right, so it's 1/2. Okay, so that's 1/2. And what's the hypotenuse?
Radical
3
3
over
over
2.
2.
F2.
What is, we're in a circle, right? What's the radius of this circle? 1. What's the length of this hypotenuse? 1. Okay? So if I want to find my sine ratio, I have to do opposite over hypotenuse. So 1/2 over 1, okay, which is just 1/2. So by shrinking our special right triangle stuff down so that has a radius of 1, well, dividing by 1, I don't really care anymore, okay? So it's the sine of our angle turned out to be just the y-coordinate there. What's the cosine of pi over 6? Let's see, what's our cosine ratio? Cosine would be adjacent over hypotenuse. And the adjacent length is radical 3 over 2. And what's our hypotenuse? 1. So again, it's just radical 3 over 2. So this is the nice part about the unit circle, is that, well, hey, it turns out that if I want the cosine of something, the cosine of some angle on my unit circle is simply the x-coordinate. And if I want the sine of some angle on my unit circle, it's simply the y-coordinate. And that is the beauty of the unit circle. Okay, so that makes it super duper nice. How do we figure out the tangent of pi over 6? What's the tangent ratio? Opposite over adjacent. So my opposite side was a half. And what's my adjacent side? Radical 3 over 2. All right. Oh, that's just the y-coordinate over the x-coordinate, isn't it? So if we want tangent of our angle, it is simply the y-coordinate over the x-coordinate. And that's the last bit. That's super nice, okay? To clean this up, those denominators reduce, and you get 1 over root 3, which then would rationalize to be root 3 over 3. So this is the beauty of a unit circle, okay? You can answer all of your sines, cosines, and tangents just using ordered pairs, all right? So turn the page. We're going to try a couple. All right. I draw little circles and dots for all of these little problems. So I'm just going to have a little miniature circle here. Where's 135? Between 90 and 180, right here. It is part of the 45, 45, 90 groups, okay? What's the ordered pair on those 45, 45, 90? Yeah, negative root 2 over 2 and positive root 2 over 2. Sine is which coordinate? The y, yep. They go alphabetical, cosine, sine. Cosine before sine, they're alphabetical, so that's a good way to remember. And so we get radical 2 over 2, and that's okay. Let's look at, I'm going to stick to, let's look at here. Let's do this one. Oh, that's let's look at 17. So again, where's 3 pi's over 4? Same spot, actually. Yeah, here's pi. I'm going to cut pi into 4 equal parts there. 1 pi over 4, 2 pi over 4. Right here is 3 pi over 4. And again, that's one part of those 45, 45, 90s. What's the ordered pair? Negative root 2 over 2, radical 2 over 2. Cosine once, just the x-coordinate, so negative root 2 over 2. All right, let's see. Tangent of 2 pi over 3. Let's try that one. I'm going to draw this. This is saying take pi. Well, here's pi. Put a nice little dot there at pi. And what am I cutting pi into? 3 slices. So 3, I'm going to do 2 little dots there. So this right there. So there's 1 pi over 3. Here is 2 pi over 3. So here is our little triangle. I can drop a little altitude if I wanted to. So now you see we have a short leg and a long leg. This is why our little tiny picture is helpful. We have a little baby short leg and a little long leg here. So what's our ordered pair? Short and long. And what was the short length? A half. So negative 1/2. And then what's the long length? Radical 3 over 2. Good. So how do we figure out tangent? Y over x. So radical 3 over 2 divided by negative 1/2. What happens to the 2's? Yeah, the denominators reduce, and it's just negative radical 3. Is this interesting? Not interesting. Let me do here tangent of 270 degrees. 270 degrees is, right here is 270 degrees. What's that ordered pair? 0, negative 1. Okay. How do we get tangent? Y over x. This is negative 1 over 0. Ooh, what's that? Undefined. When the 0 is under, it's undefined. Very good. Undefined. Let's try 19. Where's pi? There's pi. 180. And we want to cut pi into 2 pieces. So here's one wedge, here's the other wedge. So right here is pi over 2. What's that ordered pair? 0, 1. All right. Ooh. Tangent is y over x. What's cotangent? X over y. So that's going to be 0 over 1, which is just 0. Yeah. All right. Let's look at number 16 here. Yeah, this is a cosine of a negative angle, so we're going downwards, opening clockwise. 150 ends up to be right here. Not quite negative 180. So here we are. There's your negative 150 degrees. And when you draw your little picture, I can clearly see I have a long leg and a short leg. What is this little ordered pair to get to right there? Negative long leg and then the little baby shorty. So negative root 3 over 2 and then down the little short leg. So negative 1/2. All right, so cosine takes the x coordinate, so negative root 3 over 2. Now, of course, usually this goes super fast, but because I like to draw everything, it takes a long time, but I would rather you really understood what we're doing. I don't know if we're doing cosecant and secant, but we can try a few here. Let's look at the cosecant of 120 degrees. Let's see, 120 degrees is like right here. So when I draw that 120 degree angle, I can see that it's a tall triangle. So what's the ordered pair to get to that point? A little short leg and then a long leg. A short and then a long, so what are my numbers? Negative 1/2 and radical 3 over 2. So what is cosecant? The reciprocal of sine. So cosecant is the reciprocal of sine. So it would be 2 over radical 3. We got to flip the reciprocal of sine. And then we'd have to rationalize. So what do you get when you rationalize? Yep. Yep, 2 radical 3 over 3. Easy? Let's look at seat number 12. So 180 degrees is right here. What's that ordered pair?
-1.
-1, 0. Secant is the reciprocal of cosine. All right, well then that would be 1 over -1, which is this -1. Okay. Okay. Reciprocal of cosine. All right, do you have questions for me, or do you think you got it? Do you think you got it? So, okay. I do think it's a Dutchman. All right. Well, that's cool.